Yeah, welcome everyone to the Gardener review meeting today. So today is about the 1.24 release. We have 4 topics on our agenda. I will start with a new extension I'm going to present. It's called the image rewriter extension. Then we will have Oliver talking about load balancing metrics dashboards, the new ones. Then Dominic will continue with the CIDR overlap for HA VPN shoots, for HA shoots. And then we'll have the vertical pod autoscaler feature gates presented. Okay, without further ado, I'm going to start with the first topic. So as I said, this is a new extension in the Gardener space. So it's already public. And it's called the image rewriter extension. And the name already suggests it is capable of rewriting images, and it's rewriting images or system images for shoot clusters. So what does it mean? Let's maybe jump into the configuration example. The extension allows for 2 different kinds of configuration. The one is related to containerd, and the other one is related to overrides. So containerd means you can configure this extension to match suits for a particular provider and particular regions, and override or configure containerd to use those, let's say, registry mirrors. So for instance, in this case, we have the goetz IO upstream. And if you have a shoot cluster for provider local in region north, then for this particular shoot, this registry would be, or this mirror would be configured for containerd. And similar happens for the overrides, but not via containerd, but via a webhook registered for pods, more or less. So that means you have a source, in this case, Europe Docker. And again, here, for instance, for provider local and region north, you would take this override into consideration. It means whenever a pod is created that has an image with this prefix, the prefix is replaced by this target. So as I said, it's a mean to replace system images. And system images means all the images or all the workload that runs in the kube system namespace of a shoot cluster, as well as the images that are used for bootstrapping, for node bootstrapping, right? So we have the Gardener node agent, we have kubelet, we have the sandbox container image, something like this. So the extension is also capable of replacing those ones for node bootstrapping, not only the workload in the kube system namespace. Why is that useful? Well, if you host a very large scale Gardener landscape with many different providers on many different regions, you are faced with 2 challenges. One is latency. So if you have a central registry, then latency might be a point where you want to improve. For instance, if the registry is located in Europe and your shoots are located in Asia, then it may take a while to download those images from a central registry in Europe if there is no CDN in place or somewhat. And the other even bigger challenge is costs. So depending on the cloud provider you're at, they charge you for egress cost for the registries. And a way to overcome that challenges is to replicate images and bring all the container, the OCI images closer to a position where they're needed, right? So in this particular example, you would replicate the images from Europe to some kind of registry located in Asia, in the Asia region, and also for the different providers, and then you would overcome these challenges. But of course, you need to replace then the image references. How is that implemented? I can show you this in a quick demo. So maybe let's check the example. This is the controller deployment. And in this case, we have a configuration or an override configured for container D, for the provider local, for regions local. And it would be this URL, so this upstream URL for the K8s registry. And we have we have another one for some kind of full region, right? So this is only for demo purpose, of course. And so this is the first configuration I put in place, and the second configuration is slightly different. So this time we use the Quaya or Prometheus prefix, and have also two different targets here. Again, for provider local region, we will replace it with this prefix. And we have another one for demo purpose for non-existent region or for a region we don't use. Okay, so on the right side, I have my shoot cluster. It's provider local and also region local. And what we can check first is the pod. So there is already one pod with image pullback off. So this is the one I already replaced. And if we check it here, then we see that we have this regional local prefix here that is configured on the left side, right? And so this pod was not already replaced. So this is the original image reference, right? So it was just replaced from this by what we configured for the extension. And this was done by by mutating webhook configuration registered for pods. So this is the first thing I wanted to show. And the second part is the container D. Let's go into the machine directly. Container D, and we should see an upstream configuration for Europe Docker, right? No, sorry, for registry. So, all right, here you go. And also this was then put in place based on the shoot provider and shoot region. As I said, this is already considered for node bootstrapping. That means whenever the shoot is created, whenever the first node is created, it already pulls the images from the configured mirror. The advantage using container D over replacing an image directly in the shoot or in the operating system config is that container D has an automatic fallback. So that means whenever an image is not available in the configured mirror, it falls back to the upstream. So it depends on your use case at the end of the day, but the extension gives you the freedom to cover both. That's, as I said, depends on the landscape or on your setup. Okay, that's already it for the demo. Any questions? Then I'm done with this topic and hand over to Oliver. Thank you.
Yeah, good morning. I'd like to present you some dashboards today. It's a relatively small topic, but yeah, it might improve the visibility here of Istio things. And yeah, I already presented a couple of times the layer 7 load balancing. So these new dashboards make only sense or make especially sense when you enable the feature gate. That's the Istio TLS termination feature gate. And because otherwise we don't have so many metrics from Istio for the API service, because yeah, it's just the TCP stream, and with the feature gate enabled, we see the HTTP requests, and yeah, we get some more insights what's happening when people query Kube API servers. Okay. Yeah, there's also you see some screenshots here, but I like to show it, yeah, live, let's say. So basically, I just have a 1.124 Gardner version local setup here, and checking the Plutono in the garden namespace. And yeah, let's have a look at the dashboards. Okay, here we go. So that's Istio and Istio dashboards, and one the new dashboards are here. The increase the font size. Here the workload dashboard and the service dashboard. So let's start with the service dashboard. There's one thing which is yeah, relevant for all Istio dashboards. I'd like to say in the beginning. Maybe you remember when you checked the local setup, the Istio dashboards in the seed is garden case, they did not work for every case. They just worked for the seed case, as you see here. And while we introduced here those new dashboards, we also changed this a bit. So you now can switch between the Prometheus instances and check the Prometheus garden if you're interested in the virtual garden Kube API server things, and the Prometheus aggregate when you're interested in the shoot Kube API service. And of course, if you just have seed without a garden or a runtime cluster without a seed, you just have one data source here. Okay, so let's start with the Prometheus garden, because we have more metrics here. You can select the workload. The Nginx English controller might not be that interesting, but the virtual garden Kube API service. So basically those dashboards, I didn't create them by my own. I copied them from the Istio project and just stripped down things which are not relevant and added a few things which might be relevant for us. Okay, as you see here, there's a couple of metrics like the operations per second and the success rate, so kind of summary metrics. The other ones depend on the type of the endpoint. So the TCP traffic is just relevant for when Istio is forwarding the entire TCP stream. It's not. There are no data for workloads where TLS termination is active. Yeah, so the most interesting dashboards are probably, or graphs are probably those ones. You see here as the caption says, the incoming requests by source and response codes. So you might be able to see which requests are successful or yeah, not allowed, forbidden, not found requests. So it gives you a bit, it gives you some insights about the requests to your Cube API server and the HTTP response codes. And yeah, the second one I'd like to mention here is this one, because here you can see how the load balancing is working. So here you see the requests by source and upstream address, and upstream address, that's the Cube API server pod. And as you see here, we have two Cube API servers running, and here you see how Istio is distributing the traffic and see if it's even or if it's not even. And so you can see if load balancing is working for your case. Yeah, in this case, it seems to be well balanced. Yeah, and as I said, we could also check shoot metrics here. That's of course in the root namespace, and you see the same thing for the Cube API servers for the of the shoots. Yeah, and those things here, of course, are pod names. Good. Okay. That's the first dashboard. The second dashboard looks very similar. It just has another entry point. Here you start with services, and you basically get the same metrics. What you are able to see here, maybe additional to the, you don't see a summary of the whole workload for your Cube API server, but for the services. So here, with the first one, you might see when you know the load balancing a bit how it's working. The first ones are requests which are using a token for authentication, and when you switch to the MTLS service, you see requests which use a client certificate. I don't know if it's relevant for any use case, but that's the main difference here, that you have a different entry point and see the request spread by them. Yeah, that's already it. Any questions?
No questions. Thank you very much, Oliver, for presenting in the dashboards. And yeah, Dominic, it's your turn.
Yes, thanks. Let me just start the share. Teams wants me to change some settings. I hope it will work anyways. Can you see my screen?
Yes, it's working.
Okay. All right. So let me just start those slides. Okay. I just have a couple of slides to make it a little bit easier. Okay, so this is the final chapter, the Return of the Jedi, if you will, step 3 of making it possible for seeds and shoots to overlap the network CIDR ranges. It's now working also for HA control planes for IPv4 ranges. It's basically gets the same treatment as we had with the non-HA variants. It's just a little bit more complex because of the HA setup. But we'll see about that in a minute. The main difference is these mappings to the 240/4 ranges for your shoot networks and the seed pod range do only apply on an actual overlap with the seed, whereas for the non-HA control plane variant, they always applied. And why is that? So here is the default layout of how, like in a restricted view, I don't show the shoot here. It's only the control plane between non-HA and HA VPN variants. So on the left, you see the non-HA, which always has this Envoy proxy sidecar in the VPN server. It just happened to exist for this use case, and we could leverage that Envoy to make this mapping possible. On the right-hand side, you see like a toned down version. I left out some details of the HA variant. You see it's a little bit more complex. It has 2 VPN clients sitting in the API server pod. And there's also a thing called a path controller that makes sure to switch over between these two routes. If one of those routes fails, this guy makes sure that the routes inside this pod basically are swapped over, and the API server can continue sending traffic over the second fallback. And what happens in the overlap case, so if you have a shoot that has an overlap with a seed, we dynamically inject this envoy here to have basically the same kind of architecture. The only difference is that this envoy sits as a sidecar in the API server pod, and this envoy sits as a sidecar in the VPN server in the non-HA variant. As you can see, it's getting quite a bit crowded in this pod over here, and that's why we opted to only do this kind of mechanic if there is an actual overlap, because only then is it actually needed, whereas on the left side, it's always needed. You can't not have it. Okay, time for a little demo. I have prepared 2 shoots, one with an overlap with the seed and one that does not. So as you can see here in my overlap shoot, I have a pod range 1064, nodes 1054, 1043 with the services. When I look into my seed, these are the exact same ranges here. So this is the overlapping variant, and the other one just has sorry, this guy just has the default range that is in the template of the seed, so it does not overlap. Okay, when you look into the control plane, you can see on the left-hand side, I don't have the overlap variant. You only see 4 containers in the Kube API server pods, and on the right-hand side, you see 5. So that's how you can easily distinguish if you're looking at an overlap case that uses the double net mapping, or if you have the regular one. So if this gets rolled out and you have a shoot that does not have any of those overlapping side ranges, basically nothing changes for your shoot. It's untouched. And I will just show how it looks on the inside. Let me just open a quick shell here. So on the left, you see the routes are as before. You have the regular ranges here going into this IP6 tunnel device. It's different from the non-HA variant in that you have a couple more network devices here. Just to make it short, in the non-HA variant, you have a TUN device, which is able to handle IPv4 and IPv6 traffic no problem. You can send any of those kinds of IP packets in there. It will handle it. But here we don't send our traffic directly into these devices because you have 2 connections and you need to basically service both at the same time. That's why these 2 devices, in this case TAP devices, are bonded together in a bond device. And this bond device does not understand dual stack traffic. And because of that, we have to also add additional devices even before the bond device. These IP6 tunnel devices are basically used to encapsulate IPv4 traffic in IPv6. So you can have both IPv4 and IPv6 traffic. So that's why it looks different. Also here, when we look at IP tables, you see there's nothing here, no rules. We don't need to apply any nutting. It's just as it was before. And on the right-hand side, let me just open the shell real quick. We have, first of all, we have a different in the routing table. Here we have these 244, 43, and 42 ranges as opposed to the default real ranges. And in the shoot, we have these nut ranges here. And of course, when we look at the IP tables here, there has to be some magic. Otherwise, this wouldn't work. And the main difference to the previous solution we had for non-HA is, first of all, since we are now in the Cube API server pod, we had to change these nutting rules over here from using the user ID to now a group ID, because the Cube API server, both as well as the Envoy proxy use the same user. It's this non-root user, which happened to have the same ID. So I couldn't use the ID for mapping. And now I'm using a group ID. So now this works fine on both variants. And the second change we have made is we are using a different output device here, because as I mentioned before, we don't use the TUN or TAP device directly. We have to use these tunnel devices beforehand. And the problem is that if the path controller makes the switch, so if this changes from IP tunnel 0 to IP tunnel 1, then this wouldn't match anymore if you had a direct link to this device. Therefore, we use this little plus sign here, which stands for a wildcard in IP tables and allows you to match both the IP tunnel 0 and IP tunnel 1 devices, and it will work either way. If you make a switch left or right, it does just work all the time. Yeah, I think that's basically it. Other than that, the same logic applies. All the packets are basically double netted here from first the destination, mapped here to these different ranges depending on where you want to go. And once you have made your routing decision, you go into the post-routing chain where you also nut the source IP to the nut range for the pod range of the shoot. And you send it over the tunnel, and on the other end of the tunnel, it gets basically unwrapped and unpacked into the original ranges. And when it comes back, it basically reapplies the same nutting rules, and you get your traffic back. Yes, I think that's it. Okay, any questions?
Maybe one question, Dominic. So thanks for presenting. Very interesting topic. I was wondering if we have some kind of documentation we can point people to and operators to read this again, and because it's technically, I guess, very complex.
Yeah, there is like for the HA setup, there is documentation. It just currently does not mention this double netting. We could inject it here. I didn't do it until now because it's a very technical detail that might be not very interesting for a general user audience. But if there is sufficient demand, we can still maybe add a subsection for that. Yeah, that makes sense.
Okay. Cool.
Yeah, I agree. I think it can be interesting for the development side and maybe also for operators if something goes wrong, but it should actually work so that users don't have to worry about it at all, so that they can specify shoot networking ranges as they like, at least for IPv4, and don't have to care at all how the operator set up their landscapes. in theory. Let's see how it works in practice.
Yeah.
Yeah, no doubt about the functionality side. So thanks again. Okay, then we have the last topic. So yeah.
Yep. Good morning. Hope you can hear me. Let me share my screen. Okay, can you guys can you guys see my screen?
Yes, we can see it.
So feature gate. Probably I'll start with the motivation behind it. So Kubernetes introduced the ability to in-place update resources in 127 with the ability to use it by default in 133. So it got promoted to beta in 133. And on the other side, VPA didn't support it up until 1.4. Yeah, I guess 1.4 exactly. So we didn't support it until 1.4, and in order to early adopt that feature, we had to instrument our should, seed, and garden cluster specs with additional field for the vertical pot autoscaler. That enables all kinds of features, but as of now we have just one, as seen in the example below. So probably with that said, I can jump to a quick demo that I have. So on the left-hand side, we can see an example shoot spec. The difference that we introduce here is with the vertical pot autoscaler section, we have the feature gates now, and we can enable the set feature gate. On the right-hand side, I have a example deployment of a resource consumer that has a VPA resource configured with update mode in place or recreate, which in turn allows the VPA updater to actually update the pods without eviction. So that's the setup here. So here I'm in the control plane of the shoot. We can get the just see the admission controller that has its feature gate configured. And the updater has that same feature gate configured. Thus allowing both components to actually handle in-place update. So here I'm in the shoot. As you can see, we have like 3 resource consumer pods. And here on the left side, we're just watching their resources. And just to give a quick demo of how the in-place works, I can directly update the VPA resource that manages the resource consumers, and we can actually see the logs here. Let me open the logs. Data. And we can just directly update it here, just for the purpose of the demo. Okay, it usually takes roughly about 10, 15, 20 seconds for the updater to get the new request. So hopefully we'll see. Okay, it got quicker. And as you can see, the first pod got updated without eviction. And sooner we'll see the next 2 pods being updated as well. Okay, I can go back to the We've actually prepared a brief usage guide that people can get familiar with how to instrument it, some preconditions that we had. For example, for the short clusters, we allow that feature gate being specified from runtimes 133 and above. So that's one condition that should be met. And of course, we have provided references to the VPI documentation on how to instrument the VPA resource and additional, all the additional details that they have shared. Yep, so that's pretty much it for me. Just to see. Okay, well, it's still updating them. Okay, that's for my side. If you have any questions, I'm happy to answer them. Okay, no questions. Thank you.
Thank you very much, Stoyan. So this was the last topic for today. Thanks to all presenters and for the audience for listening. A short reminder, the next community meeting is already scheduled for August 6th, which is next week, and it's going to be about the Kubernetes 1.33 release. So would be glad to see you there as well. And until then, have a good day and see you next week. Bye-bye.
Bye.
Bye. You. Bye-bye.
Bye.
Bye.